Hey everybody, today we will be going over electron configuration. There will be two videos attached to this topic. Please follow along in your guided notes on each of these videos. You will also have to write a few things on a separate sheet of paper and submit them through Schoology. Those instructions should be there for you. But let's go ahead and get started with the notes here. This is the first video. There will be two videos covering this topic. The two learning targets that we will be focusing on today are, I can use the periodic table to determine the location of electrons. And when we talk about location, we're talking about the energy level, which goes back to the Bohr model, the sub-level, which would be S, P, D, and F, and the orbitals, which are individual orbitals on each of the sublevels. So I can use the periodic table to determine the location of electrons in an atom and write the electron configuration. So if you're not sure what an electron configuration is, that's okay, because that's what this video will explain to you. Our second learning target will also be dealing with electron configurations. It states, I can use the Aufbau principle. So take a look and see how Aufbau is spelled. It's A-U-F-B-A-U. The Pauli exclusion principle. Also take a look at how that is spelt. And Hund's rule to draw an electron orbital diagram of an element. So these two learning targets will be the focus of the videos. The first video is going to focus a little bit more on the first learning target, and the second video will go into more details on the second learning target. All right, so let's review some prior knowledge. What are the key discoveries that influence the quantum mechanical model? We've been going over the quantum mechanical model for the past few days, and the whole point of it is to get us set up for electron configurations. So our first key discovery is the photoelectric effect. So the photoelectric effect revealed that electrons can interact with light. Our second key discovery is wave-particle duality. Wave-particle duality explains that electrons have wave-like properties. And the Heisenberg uncertainty principle. This one is always a little bit of a mouthful to say. The Heisenberg uncertainty principle states that only the probable location of an electron can be determined, not the exact location. So these key discoveries led to the quantum mechanical model, and let's specify exactly what are the characteristics of the quantum mechanical model. Here are the significant characteristics of the quantum mechanical model that are important to understand electron configurations. Electrons exist on discrete energy levels called quanta, and quanta is the plural form of quantum. Electrons behave like particles and waves. And they can interact with light. Electrons can be found in a probable location. That goes back to the Heisenberg uncertainty principle, a probable location around the nucleus. These are called atomic orbitals. And if you remember, the atomic orbitals are not like planetary orbits. They're different shapes that surround the nucleus. So they form various shapes related to the electron's energy level. Now that we have reviewed the significant characteristics of the quantum mechanical model, let's review atomic orbitals before we really jump in to electron configurations. Here you can see a table that lists out the different information for atomic orbitals. We have the sublevel, the shape, the number of orbitals, and the number of electrons. In the table, you see only the shapes are provided for you. What I would like you to do is pause this video right now and try to complete the table on your own without referring to any notes. Give yourself about 30 seconds to a minute to do that, and when you've completed, you can go ahead and play this video. Okay, now let's go ahead and double check your answers. The first sublevel is sublevel S. That is because there's a spherical shape right there. There's only one orbital on the S sublevel, and 2 electrons can fit into that one orbital. The second row has a shape that kind of looks like either a dumbbell or a peanut. That's going to be the P sublevel. It will have 3 orbitals and can fit a total of 6 electrons. The third row, the shape kind of looks like a clover. That's going to be our D orbital, and there are 5. It's the D sublevel, and there are 5 orbitals on there with 10 electrons in total. And the last row is kind of a weird, funny shape. That's going to be the F sublevel. There can be 7 orbitals on the F sublevel with a total of 14 electrons. So this table is very important when it comes to electron configurations, because we're actually going to pinpoint exactly where an electron is in an atom, whether it's on the S, P, D, or F sublevel, and on which orbital it is within the sublevel. So what's the point of all of this? The discovery of atomic orbitals shows us that the Bohr model, which we started in Unit 1, is an incomplete representation of the atom. So it does have good information that really helps us to understand things, and we'll be using the Bohr model throughout the whole year, but it's incomplete. It really doesn't tell us where electrons are. Therefore, a more accurate representation of how electrons orbit the nucleus is needed. And this is where electron configuration comes into play. So what is electron configuration? Well, electron configuration, or the electron configuration of an atom, is an updated model that shows the arrangement of electrons orbiting the nucleus. And this is all according to the quantum mechanical model. So that's why we have to go through the quantum mechanical model, so you have an idea of how this arrangement was even discovered, right? Electrons are acting like waves. They're not really, they're kind of hard to find. So we just have this probable location that can be determined through atomic orbitals. Electron configurations include representations of both the energy levels and probable locations of electrons in the atom. So what does an electron configuration look like? Well, electron configurations can be drawn using electron orbital diagrams, and that's what's shown below. They can also be written in long form or shorthand electron notation. The shorthand notation is also called noble gas notation. And we won't be going into detail of noble gas notation until a little bit later, so you can kind of hold off on that. But I do want you to take a look at the images below. This first one here is an image of the electron orbital diagram. Each of these boxes here represent the orbital, the atomic orbital. So we have one S right here. That S is referring to a spherical shape. The arrows represent the electrons. So this box is telling me that I have an S sublevel at the first energy level And there are 2 arrows in there. So that means I have 2 electrons that are hanging out in that S sublevel. What you'll also find out is that every energy level doesn't have every sublevel. Like the first energy level here, it only has the S sublevel. The second energy level, we see that it has an S sublevel and a P sublevel. You'll also notice that the electrons fill the orbitals in a certain way. And the next video is going to go into more detail about how the electrons fill those orbitals. Make sure you're always looking at where the increasing energy is, because electrons fill the lower energy before the higher energy orbitals. You'll also see that the direction of the arrow is important. In the next video, we'll talk more about an electron spin. And there's always going to be one electron that's spinning up and the other one is spinning down. Electrons like to hang out in pairs. Also take a look at the electron notation on the other side of the screen there. You'll see that the 1 coefficient represents the energy level, and the S represents the sublevel. The superscript up there, that's not an exponent like in math. The superscript represents the number of electrons on the sublevel. So if we look at the electron orbital diagram, we see 2 electrons, 2 arrows in that box. So there must be 2 electrons in the 1s orbital. And we can see that written here as well. And as we keep going, there are 2 electrons in the 2s. That's written right here. And then there are 3 electrons in the 2p. And we can see that written here. So we can either draw out an electron configuration as an orbital diagram, or we can write it out as electron notation. The next video will go over some examples for you so that you can get some practice both drawing the electron orbital diagrams and writing the electron notation.